Good morning, dear students. Radicals and radicand, article 2.3 of chapter number 2. This is the topic for today. Here is the concept. Here is a concept of radicals and radicands. If n is a positive integer greater than 1, positive integers are also known as natural numbers, and here is the condition that this n, here is the index for this for this radicand. It must be greater than 1, and it is also a positive integer, and a is a real number, and this a must be a real number. Then any real number x such that xn is equal to a is called the nth root of a, and is in symbols it is written as x is equal to nth root of a. It is in the radical form, or x is equal to 1 by n. It is in exponential form. In the radical nth root of a, the symbol, this symbol is called the radical sign, and n is called the index of the radical, and the real number a, this nth root of a, this n is called the index of the radical, and index of the radical at the real number a under the radical sign is called the radicand or base. This a is the radicand or base. Note it down here that 2 under root a is usually written as under root a only. It is understood that here the index is 2. Difference between radical form and exponential form. In a radical form, the radical sign is used such as this: x is equal to nth root of a is a radical form. Its more examples are 3 under root x is equal to third root of 5x, or fifth root of x square are examples of radical form. And in exponential form, exponential is used in place of radicals. X is equal to a 1 over n. It is in exponential form, and its some of other examples are x 3 by 2 or z 2 over 7. These are some more examples of exponential form. Move on to exercise 2.3. Problem number 1. Write each radical expression in exponential notation. Each radical expression in exponential notation, and each exponential expression in radical notation, but you know, do not simplify it. Here third root of minus 64, and you know that when I transform this radical equation into a exponential form, minus 64 1 by 3, this index will move on here in exponential form. Only I have to transform it like this: 2 3 over 5, it will be written as fifth root of 3. Here is the n is here 1 over n, here the n in radical form. Minus 7 1 by 3, it is written as n into under root 7. Here n is equal to 3 minus 3 into 7. Why minus 2 over 3? It is again this is n, put n is over here, and y minus 2 under root. So this was the question of exponential notation. I have to transform it into radical form, and this was the question of a radical form. I have to change it into exponential form. Tell whether the following statements are true or false. Here 5 1 over 5 is equal to under root 5. It is false, because this 5 under root 5 will be like this. So this is correct, this is false. 2 over 3, it is written as third root of fourth. 4, it is true, because 1 over 3, this is n, and I put here in radical form, and 2 power 2, it will be 4, so it is true. Under root 49 is equal to under root 7, it is false, because under root 49 it will be written can be written as 7 the square over under root. This under root and square will be cancelled, only 7 will be left, so this is correct, but this statement is false. 3 under root x power 27 is equal to x3, you can calculate it yourself, it is also false. Simplify the following radical expression. Index 3 and radical sign minus 125. This 125 can be written as 5 power 3. So this 5 can be written simultaneously, 5 multiplied by 5 multiplied by 5, and here is the minus sign, you can put here minus 5 multiplied by minus 5 multiplied by minus 5, it will be minus 125. So together you put it into the exponential form, minus 5 to the power 3. Here this index will be cancelled by this power, it will be minus 5. 4 under root 32. The fourth root of 32 can be written simultaneously as, because 2 to the power 5 2 power 5, it will give you 32. So 32 to the power 5, 1 2 3 4 5, the 2 is simultaneously multiplied by here, but you choose this pattern to the power 4, because here the index is 4, it will be easy to cancel. 4 and 4 4 4, this 4 will be cancelled by this, 2 will be left. But in this base, in this radical 2 which is left, here the index is present, so it will be 4 under root 2. This will be the answer. 5 under root 3 over 32. So 3 over 32, here it is the property number 2, this index can be separately move over this 3 and 32, 5 under root 3, 5 under root 32. So 5 under root 3, 2, 32 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2 to the power 5. This index 5 will be cancelled by this, only 5 under root 3 over this 2 will be left. 3 under root minus 8 over 27. This 28 can be 2 to the power 8, 2 power 3 can be written as like this 8, and 3 power 3 can be written as 27. So this 2 over 3 can be written as minus 2 over 3 minus 2 over 3 minus 2 over 3 together, minus 2 over 3 power 3, these will be cancelled by this index, and minus 2 over 3 will be left. Enough for today. Goodbye. Allah Hafiz.